Okay, welcome to another example of complex numbers. Okay, this one says if z equals minus 3 plus 2i, we want to evaluate the conjugate of z, read as z bar, and we want to verify that z times z bar is in fact real. Then we want to use this, that 1 over z equals z bar divided by z times z bar, to find 1 over z in the form of a plus ib, and this is just a little notation saying ab is an element of real, so a, b are both real numbers. Okay, a and b is a real number, but this part of the complex number is the imaginary part, but b is still a real number. Okay, so it looks difficult, but it's not. Okay, the first one, if z equals minus 3 plus 2i, that means z bar is minus 3 minus 2i. Okay, if we take z bar, so we're multiplying minus 3 plus 2i with minus 3 minus 2i. Okay, what we end up getting is we're multiplying two complex numbers, and one is a conjugate of another. Take this number, square it, so minus 3 squared is 9. Put a plus sign, take this number, square it, and you get 4, and you end up getting 13. Okay, and that's always the case, okay, when you're multiplying two complex numbers and one is a conjugate of another. Okay, so you do get, in fact, a real value, you get 13. Now, we're going to use that to find 1 over z in the form of a plus ib. Actually pretty easy. So 1 over z, we know that equals the conjugate of z, okay, over z times z bar. Okay, so 1 over z is actually saying 1 over minus 3 plus 2i. That is in fact, okay, so the conjugate of z is minus 3 minus 2i divided by z times z bar. We found that up here, divided by 13. So all we end up getting is minus 3 over 13 minus 2 over 13i. So pretty easy example. May have looked difficult with the question, but in fact it's not. Okay, so a is minus 3 over 13 and b is minus 2 over 13.